Welcome. In this video, I want to show you a lecture that I did on inheritance. I am teaching a course on object-oriented programming and design. We got to the topic of inheritance and I figured I would record it and share it with you here on YouTube. So if you are learning object-oriented programming or you're using it and you aren't very quite sure about inheritance, then I hope that this video will shed some light to you and perhaps there's something that you can pick up from it, or perhaps just to grasp a different mentality on how to think about inheritance. All right, so again, I hope you enjoyed this video, and most importantly, I hope you learned something new. Today, we are going to talk about inheritance, and inheritance is quite an important aspect of object-oriented programming, and you'll see one of those reasons as to why it is so important and what kind of things we get out of inheritance. So we learned in the past, that a class is a description of an object which has data and function members, right? So here we have a class. We have been using the class of a dog, right? And in this class, we're able to describe certain things, like we're able to describe this dog, right? And we have some data members, so we have a weight and an age. And then we have function members. Some of those function members will be the constructor, which is a special type of function member, right? So the constructor is what allows us to construct the object. We have a destructor, which is another special type of function member, which destructs the object when it's no longer needed. And then we can add our own custom functions, like the bark function, right? We could say that the dog is able to bark. We also learn that an object could contain other objects as data members, right? So here we have an object which is a heart, right? And the heart has its own data members, has its own function members. You know, it has blood, it has it's composed of many things. It has functionalities, it can pump blood and whatever. And this object is a member of dog, right? So dog it's somehow made up of a bunch of things, and one of those things is a heart. Right? So we have a bunch of data members, function members. Some of those data members are other objects. Now that we've known this, we can do pretty much everything with object-oriented programming, right? Pretty much everything, I would say. But there is a problem. And to actually figure out what this problem is, let's go through a little exercise. So back in the beginning, when we first started talking about object-oriented programming, I gave you this dog, right? And then within this dog, we said, okay, let's actually define its characteristics and functionalities, how we say this dog is, and then the things that it can do. So some of those characteristics would be that it has an age, right? It was born and it has a particular age. It has a weight, right? We can weight the dog and it has some weight. It has a heart, which is another one of its members, right? That's why the dog is alive. And in some of those functionalities is that it's capable of breathing, it can eat, and it can bark, right? And I'm sure that you can come up with many more characteristics and functionalities based on the dogs that you own, or if you have pets and if you have dogs, or you know, we all know what a dog is. So you have all these different characteristics and functionalities that you can specify about this dog. And based on these, we can create a class, and then we can create instances of that class which represents a dog, or you know, any dog that we're trying to create. Now here's another one. Here's a new one. Here we have a cat, right? The cat, we can also describe it using the same concepts: data members and function members, characteristics and functionalities. The first thing is, of course, it also has certain characteristics, has an age, has a weight. It also has a heart. It has some functionalities. It's able to breathe, it's able to eat, and they can make hairballs, all right? And again, I'm sure you can come up with more characteristics and functionalities for a cat, but let's just say that we have just these 6 for now, right? So we're able to describe a dog and a cat. Here's a mouse. Doing the same thing. A mouse also has an age, has a weight, has a heart. Functionalities: it can breathe, it can eat, and they like to collect a bunch of food, right? They like to get a bunch of food, roll it up somewhere, and they have food just in case they are not able to find food later on, right? So that's a functionality that they can do. All right, let's do another one. Here's a bunny. The bunny has an age, has a weight, it has a heart, right? And it also has certain functionalities. It can breathe, it can eat, and they move around by hopping, right? So it can hop. Okay, let's do another one. Here's a horse. The horse also has an age, has a weight, has a heart. It can breathe, He can eat, and it is also able to throw kicks. All right, here's another one. Here's a cow. The cow has an H, has a weight, has a heart. It can breathe, it can eat, and it can moo, right? It makes the moo sound. All right, here's another one. There's a lion. Has an H, has a weight, has a heart. It can breathe, it can eat, and it can roar, right? That's something the lion can do. All right, here's a hippo. The hippo has an H, has a weight, has a heart. It can breathe, it can eat, and it can also swim, right? They swim around in the lake or wherever they live. Here's an elephant. Has an H, has a weight, has a heart, has a tusk. I know this one doesn't, but let's suppose that it has a tusk, right? So it has a tusk. It's able to breathe, and it can eat, right? All right, here's another one, a giraffe. The giraffe has an H, has a weight, has a heart. Its neck has a length, right? We can describe the length of the neck. The giraffe can breathe, and it can eat. Do you guys see the problem? What's so problematic about all of this? I mean, imagine we have to do this for 100 animals or all the animals in the world. You would have to write the H, the weight, the heart for every single one of them. And you will also have to specify the functionality that it breathes and it can eat. Right? We are repeating this over and over again, right? Over and over again. So that is the problem. It's too many repetitions. And even though we can live with that, right? There's okay, we can live with that. We can make it work. We mentioned that when we start repeating code, that's not a good idea. So what do we do? So let's go back a little bit and let's discuss a little bit. What did we do when code started to become too repetitive? So we mentioned that when code is repeated a lot, we generally create a function, right? So if you have a bunch of if statements, they look alike, or a bunch of loops, they look alike, or some logic that looks alike, you say, I can make this into a function, and then I just use that function wherever I would repeat this code instead. And that way you don't repeat writing the same code more than once. You don't have to maintain the same code more than once. Everything is just much more easier to use. Now the problem again that kind of builds up is that what do we do when a variable and these functions, or when variables and functions are repeated so much, right? So the variables themselves and the functions, they repeat so much. You might say, well, we make a function that uses functions. And I say, okay, that makes sense. But then what do you do when all these variables and functions are part of objects, right? Because all these members that we talked about, all of these things, they're part of an object. And then you do it again, this is part of another object. We can't just nest it into functions. How do we nest inner members of an object into functions? So generally, we don't have that option anymore. So we need another way, but not just any other way. We can't just do it whatever. So here is an idea, all right? So we define ideas using a class. Now, I'm using the word idea as a synonym for the word object. I know they're not synonyms, but I'm using them as synonyms. Why? Because when you have a dog, when you think of a dog, when you write a class for a dog, like we did earlier with the dog class, and how we did for the other 9 animals, is what we do is we actually describe an idea about this object, right? We don't actually get a dog and like shove it into the computer. Don't do that. That's mean. But what we do is we have an idea of what a dog is. And based on that idea, you're able to describe the dog. You're able to create the class. You're able to say it has this data and it has these functionalities. So everything is based on an idea that you have of the object. If I ask you to make a class that represents a dog, and then I ask all of you to do that, all of your classes will look slightly different. There will be a lot of things in common, which is good, right? If our ideas of a dog are completely different, then we cannot even talk about dogs. How could we talk about dogs if our ideas of them are completely different? So there will be a lot of overlap, but even then, there will be a little bit of a variation, because your idea of a dog might be different. Maybe you're thinking of a pet. Another person is thinking of a guard to a farm, and so on, right? So here, we define an idea, an object, using a class through data members and functionalities. Now, what's interesting is that some of these ideas that we have, they overlap. So the dog idea and the cat idea even though they're two separate objects, even though they're two separate ideas, there's a lot about these two ideas that are overlapping, that have in common. So you might say, well, they're both what? They're both able to run, they both breathe, they both have a heart, they have an age, they have a weight, they're both pets. There's all these things, right, that they overlap in. They're completely different. They're two separate objects, two separate ideas, but there's just so much about the two that is in common, that it's the same. They both have hair. Okay, there's some dogs and cats that don't have hair, but you know what I mean, right? There's a lot of things about these two that overlaps. So here's an idea. What if we could define the stuff that overlaps among ideas first? So we describe everything that overlaps on all the ideas that we have. Then the difference of those ideas, we define them later, separately. Okay, so to understand this, let's look at some examples. So here I have a dog and a cat, right? Here, a dog and a cat. This was supposed to be animated. Wonder what happened. But anyways, here's a dog and here's a cat, right? You can describe the idea of a dog, kind of as we did earlier. Age, weight, has a heart, it can breathe, it can eat, and it can bark. And then you go and you look at the cat, and then you say, well, the cat also has an age, a weight, a heart, it can breathe, it can eat, and it makes hairballs, okay? There's a lot of overlap in these two ideas. What is the overlap? The age, the weight, the heart, it can breathe, and it can eat. Those 5 things in this idea of a dog and in this idea of a cat, they overlap. So what can I call the overlap within the context of a dog and a cat? Well, I can call it an animal, right? There's more things you can call it. You can call it a living organism if you wanted to. That's another way to describe the overlap. A living organism, you could say, well, that's something that has an age, weight. Okay, maybe not all living organisms have a heart. Okay, we won't make biologists angry, but let's just say, you know, they do. So all have a heart, they breathe and they eat. Okay, maybe they don't all breathe and they don't eat how we conventionally think of eating, but you get the point. Another way would be a pet, right? Instead of animal, I could say, well, they're both pets. The idea of a dog that overlaps with the idea of a cat is something that I can describe as pet, right? And so on. A mammal would be another one. And I'm sure there's a bunch more that we can think of. Well, here's another one. We have a square and a circle, right? So square is this thing that has 4 sides. They're all the same, right? And in the square, you can give characteristics of the square, which is it has a perimeter, it has an area, right? Those are some characteristics of the square. Then you go look at a circle, and the circle is this thing that has infinitely many sides. It has a radius, and it also has a perimeter, and it has an area. So they overlap in the idea that they both have perimeters and they both have areas. Well, how can we describe that overlapping idea? Well, we can describe it as a shape. We can say all shapes have a perimeter and an area. So the overlapping idea between square and circle, it's the shape. Okay, here's another one. We have a car and we have a bus. The car is something that moves very fast, relatively speaking to humans. It gets you from point A to point B, and let's just say that's it, right? And a bus is something that's also relatively fast to humans, and you can get a bunch of people from point A to point B. So there's 2 things that these 2 overlap. The fact that they go from point A to point B at a relatively high speed, and they take people from point A to point B. What do we call that? We can call that a vehicle, right? So the overlapping idea will be that it's a vehicle. Here's another one. We have a Walmart and Best Buy, and we're not getting ad revenue for using them. All right, so we have Walmart and we have Best Buy, okay? Walmart is a place you go in and you look for things that you want to buy. You can see them, you grab them, you go to the cashier, and the cashier charges you an amount of money. You pay them and you take those items. Best Buy, similar thing, but it's all related to electronics, right? So what is the thing that they overlap? The fact that you can go into this establishment, you can get items, you go to a cashier, and then that cashier charges you money for it, and you pay for it, and you take those items home. What can we call that? That overlapping idea. We call that a store. All right, so here's another one. Chrome and Firefox. Chrome is this thing made by Google, which it allows you to go into a website, get the contents of a website, and display it. It lets you log in with your Google account, and it synchronizes the history and everything. Then you go and you look at Firefox, and Firefox is this program that is designed and developed by Mozilla, and they also let you go into a website and display its contents. And I also believe they let you log in with your Google account, and I don't know if they have synchronization of browser among devices, but there's an overlapping idea. The overlapping idea is that we can go to a website and display those contents. What do we call that? We call that a browser, right? I hope you're starting to see the pattern here, right? So here's a table. A table is something that you have on your dining room where you can put, silverware, you can put food, you can put whatever that you're going to eat, you can put it on top of the table, right? And here you have a desk, which is a thing that you have maybe at your office, and you're able to put your keyboard, your mouse, your computer, your pen, pencil, notebook, right? So what's something that they both have in common? Then you can put things on top of them. So what do we call that? Well, we call that a surface. Okay, great. So let's go to another one. Here's a hammer. The hammer is something that allows you to do this thing that would be difficult to do otherwise if you didn't have it, like putting a nail onto the wall, right? Without the hammer, you wouldn't be able to do it. It would kind of hurt if you were to punch it, right? Here you have a clamp. It's something that would allow you to put something in a very fixed position that if you didn't have this clamp, it would be very difficult to keep that thing in that same position. So the idea is that these two allow you to do things that otherwise you couldn't do by yourself in a humanly possible way. What do we call those? We call those tools, right? So that's where they overlap. And the last one, the last example is here we have Earth, a place where people live, and there's a bunch of rocks and elements and water and living organisms and people talking about programming and inheritance. And then on the right we have Mars, which is a place that apparently maybe has no living organisms, but it has a bunch of rocks, it has water and a bunch of gases in it. What is the thing they overlap? That they're both massive, they both have a bunch of different elements and rocks and water and gas and all these things. So what do we call that thing? Gravity would be another one. They both have a gravity. So we call these things a planet. I hope that with all these examples, you're starting to see a pattern here, that you're starting to see what we're actually doing. And what I want you to realize is that I want you to notice that everything about the idea in the upper level is 100% relevant to the ideas in the lower levels, which means everything related to planet, however you can describe a planet, just a planet in general, every description that you have of a planet, whether that is data or functionalities, they all apply to Earth and they all applies to Mars, right? Everything. If there is something that doesn't apply to Earth, then our definition of planet is either wrong or Earth is not a planet, all right? There's something weird going on there. If we look at, let's look at another one, the browser. Everything that a browser can do, display contents on the website, and all these other things, everything that a browser can do, how we define a browser, everything about it has to be fit also to Chrome, and it also has to fit Firefox. So everything that I have relevant on the top level is relevant to the lower level, 100% of it, right? Everything relevant to a vehicle is relevant to car and bus. Everything relevant to a shape is relevant to square and circle and so on, right? Okay, what do we call this? We call this inheritance, right? This is where inheritance comes in. And basically this bullet right here is the reverse of this bullet, right? And it's the lower level ideas inherit all descriptions of upper level ideas. So everything at the bottom level has everything that the upper level has described. So the upper level describe, a big massive thing that has rocks and gases and all these things, and then you say, okay, well, everything that Earth is going to be whatever this is plus something else, but it's going to be 100% relevant of what planet is onto Earth. And same thing with all the other examples. So the lower level ideas inherit every description, every data member and functionality of upper level ideas, everything. Okay. As you can see, we can use this for our repeated members. We can say, hey, all the repetition it's where the ideas overlap. Everything that overlaps, that's a repetition. Can we give the repetition a name and describe it as a unique idea, as a unique object? And the answer is, for the most part, we can. So here is all of our 10 animals that we used as an example in the beginning, right? They had something that all 10 of them had in common. They all had an age, had a weight, had a heart. They can breathe and they can eat. Those 5 things, within the context of these 10 animals, they represent a unique idea. And I can use that idea as an upper level, as a base. And that idea would be an animal. All of these 10 things share something in common. And that thing that they're sharing, I'm calling it the idea of an animal, right? And so now an animal, what I said is I can go and describe this more upper level idea, right? I can go and describe it. So the upper level idea is that it has an age, it has a weight, it has a heart, it can breathe, and it can eat, right? All right, so let's just say that all animals, again, within the context of these 10 animals, right? This is the 10 animals that we care about. So just by looking at these 10, I can make this observation. Another name that would be perfectly fine would be to call this a mammal, right? This would also be perfectly fine. That say that all these 10 are mammals, and therefore they have an age, weight, heart, they breathe, and they eat. But I picked the word animal because why not? And so now, we already have described the upper level idea. Now let's describe the lower level ideas as I inherit my upper level idea plus something else. So a dog is everything that an animal is plus it can bark, right? So now if I mix this table, and this little box together, we would get what we had all the way back here, right? Here's where it is. We have age, weight, heart, breathes, eats, and barks. I have all these 6. Well, when I come back to my big graph here you go. I have age, weight, heart, breathe, eats, and barks, right? It has all 6. I have separated them, but they still together, right? So dog is everything that animal is plus it can bark. And then I do that for the rest. A cat is all those 5 things plus it can make hairballs. The mouse, those five things plus it can collect food. Then the bunny can do those 5 things or has those 5 things and it can hop. The horse can kick. The cow can moo. The lion can roar. The hippo can swim. The elephant has a tusk, and the giraffe the giraffe's length can be specified. So now notice how much repetition do we have? We have 0 repetition, right? Absolutely 0 repetition. Everything only exists once. The idea of animal exists once and describes all those things, and then all those things at the bottom say, look, I am that plus this extra stuff, and I don't have to re-say those things. And that becomes powerful in inheritance and object-oriented programming because we avoid having all this repetition. Okay, so how do we do this in actual code, right? Because we show it, but how do we do this in code? So first, just as we did here, we first have to describe our upper level idea, right? So in this case, the idea is animal. So I am going to create a class for my animal idea. So here's my class, and I call it animal, right? And we say that all data members, we make them private, right? So here's my age, here's my weight, here's my heart, these top 3. And then I have 2 functions. It can breathe and it can eat. And the eating function, I gave it a parameter just for fun, right? And the parameter is how much are you going to eat in pounds, right? 10 pounds, 20 pounds, 100 pounds, whatever the animal is supposed to eat, right? So here's our 5 members. So based on this little table that we have here, I have created this class. 3 members, 3 characteristics, and 2 functions. Okay, fairly easy. You know how to do that now, all right? Now, we're going to go and create the lower level ideas, right? So our class dog, if I go look at dog, what does dog have? Dog only has this. He has a functionality, which is called bark. So my dog, I have a function called bark, okay? No parameters, just a simple function called bark. I do the same for cat. So my cat had what? It had the ability to make a hairball, right here. So I need to make a function for do that. Okay, make hairball. All right, so here we have our function. Now let's go for giraffe. A giraffe had a length to its neck, and that's a characteristic, which is another data member. Okay, so my giraffe has a data member, which is the length of the neck, and is private because we make data members private, and we also give it a function, a getter, for the length of the neck, right? So the getter is get neck length, right? And even though I don't specify that here, we know that our object-oriented good practices is for our data members to have getters. So I gave a getter to my neck length of the giraffe. Okay, so now I have described, and I'm not going to do for all 10 animals. I just picked these 3. I picked dog, cat, and I picked giraffe, right? So here you can see the additional things that the idea of a dog is. The additional thing that the idea of a cat is. Same thing for giraffe, and so on. Third, the third thing we're going to do, the third step is we actually have to merge the ideas, right? I need to specify these arrows that you have here, this arrow coming down and pointing at horse, the arrow pointing at giraffe, pointing at dog and cat. We need to specify that arrow, right? And the way to do that is very simple, actually. So here in our class, so our first we create our classes for the ideas at the bottom level. And then what we do is we say, I want to connect that class to the upper level. I want to be able to inherit from the upper level everything about it. And to do that, you just look at this right here. Boom, I just add this. I just say, I have a class named dog, and then I put the colon, and you can think of this colon right here as inherit from. So dog inherits from animal, right? And then I do that for cat. Class cat, which inherits from animal. Class giraffe, which inherits from animal. And that's it. When I do this, by simply just doing this, what I'm saying is I'm saying, hey, everything about animal, that's also me. All right? Give me all the members that are in animal. They're part of me. They're also my members. And on top of that, I'm going to add a few more things, right? So the dog adds bark, the cat adds make hairball, and the giraffe has a data member, which has the length of the neck, and a public member to get the length of the neck as a getter, right? So this is how we do inheritance. So everything you have learned so far, it's the exact same thing. The only thing that we have added to this new thing is, other than thinking of ideas and objects as things that can inherit from each other, implementation-wise, the only new thing that we have added is the fact that we do colon, or one colon, and the name of the class that we wish to inherit from. The rest is the same. We still define functions, data members, we still have getters and setters, we still have public and private. Everything is the same. The only difference is you're saying, hey, give me everything about that upper class, because that's part of who I am. Okay? So now, let's talk about a few terminologies so that you know what I'm talking about when I use these terms. The base class, that's the class being inherited from. So base class here is the animal class. So the animal class is the base class in this inheritance. Okay? For example, the animal class, sometimes we call it the parent. I like to call it the parent sometimes. So the parent class is the class that you inherit. It's kind of, we get the concept of inheritance also from us humans. We inherit certain things from our parents. I get my dad's forehead, my mom's nose, and so on, right? So you inherit things, characteristics, and functionalities from your parents, right? My mom's knee hurt, mine sometimes hurt. So she gave me that functionality. It's one that I wish she didn't, but she gave me that one, right? So sometimes we call it the parent function, the one at the, not the parent function, the parent class. So the idea or the class on top, we call it the base class. Sometimes we call it the parent class, and sometimes we call it the superclass. This is more of a Java terminology. I myself never use this term. I don't know. I like parent and base class, but that's just me. Then we have the derived class. The derived class is the class that is inheriting from the base class, or from the parent, or from the superclass. In our examples, that will be dog, cat, giraffe, or sorry, not classes. So any of those that we did, any of those 3 classes is that we have derived. Those are called the derived classes. And here's an example of how they look. You have the name, so derived class name, so the name of the class that is deriving from the base class, and then we have the name of the base class, or also the parent class, right? So this is the notation of inheritance. The new name for the new class that you're making, colon, colon, saying, give me everything about that. This is who I am inheriting from. This is my parent, let's just say. And of course, if the base class is called a parent, then the derived class is called a child, right? So same analogy. So parent, child, base, derived, and then of course they sometimes use superclass. Okay, no questions so far, right? I haven't added much new. I just added some terms. So let's go on. Any questions? No. Okay. So we're going to start adding some things because we now understand the concept of inheritance. But you know, one thing is to understand the theory, and then another thing is to go and actually figure out how exactly these things are implemented, and if there's any potential problems that come up as we implement these new ideas. And it turns out that because we have inheritance, we come up with new problems that we need to be able to resolve and be able to use properly or resolve properly so that we can use inheritance properly. So remember about the access modifiers, right? So we had something like public and private, right? And we said that private members are members that can only be used within the class, only within the class. Public members are members that can be used within the class, but they could also be used, or they could be called, or they could be invoked by the outside. So the outside, you know, you're in the main function, you create an object, you want to use one of its members, the only ones you have access to are the ones that are marked with public, right? And so these are private. What happens if you then have a class, let's say class A, and then class A has a private member called data member, right? So class A has a private data member. And then class B inherits from class A. And then it has a function, and within that function, I would like to use this private member of A, right? Because I told you, everything that is part of A becomes part of B. Everything that is part of the base class becomes part of the derived class, which means you would think that every member that the A class has, or that the base class has, the derived class should also have it. And the answer is that it does. The derived class has every member of the base class. The problem is that C++, the way we go about object-oriented programming implementation is that we respect the access modifiers. So if we say that a member is private to one class, it's private to that class. It doesn't matter if another class has inherited from it, right? We have to respect the fact that it is private. We respect the privacy of the class. We respect the privacy of the members of that object, which means that even though I have inherited these private members, I cannot directly use them, okay? I just can't. It just, you know, you can think of a, maybe it might be an okay analogy, but you can think of a dog, right? The dog inherits the fact that it has a heart. But even though it inherits the heart, the dog itself doesn't have access to it. The dog cannot like take out the heart and be like, hey man, how are you doing? Or pump faster, or, you know, or relax, don't get scared. You know, the heart is just there, and it's part of the idea of it being an animal, a living organism, or whatever. So the dog in here, in this example, it inherits from heart. It inherits from animal, and it inherits the fact that it has a heart, but that heart is private, which means the dog doesn't have access to the heart. It's within it, it's part of it, but it doesn't have access to it. I can't, like, you know, again, as a human, I can't like go in there and just play with the heart. I can't do that. I'll probably die. So the point here is that when we create these classes, even though I inherit from the base class, even though I inherit everything about it, I don't have access to its private members. C++ respects the member access, right? It's respected. So I cannot use private members. However, I can use public members, right? So here's the same class A, with the same data member, but now I make a getter function, right? So I get data member, and then I inherit B. B inherits from A, and then within that same function that we had earlier, instead of using the private member, I use the public member, get data member, right? And now this is okay. So what I'm saying is that from your base class, you can only use its public members. You cannot use its private members, even though they're part of who you are. They're part of the derived class, right? They're members of the derived class. You just don't have the ability to touch them. That's just kind of how it is, all right? Okay, so quick little problem. What if we wanted a member of the class to be available for the base class, to be available for the derived class, but not the outside, right? Nothing on the outside, just the base and the derived class. So to do that, we need a new access modifier, and we call that protected. So here is our animal class, right? Our animal class has 3 data members, age, weight, and heart. And then I went and I changed the function breathe and eat, and I made it protected, right? So this is a new label you have never seen before. And it works the same as private and public, except this is a new type of access. And protected, what it does is it says, hey, I can be used from within the class, meaning within animal, and I can be used within any class that derives from me. So basically dog has access, which inherits from animal, has access to the protected members. So it has access to breathe, right? And if I want to eat in here, then you would have access to eat as well. So any derived class has access to all protected members and public members. But public members have access by anyone, right? Public members, they don't have any limitation. They're accessible by the public. But private is only accessible by the class, protected, accessible by the class, and the classes that derive from it. Which means that if they're protected, you cannot use it from the outside, right? So breathe, this one, is protected. It's not public, it's protected. So here I create a dog instance, and then I try to use it, that breathe, that's not allowed, right? Breathe cannot be used from outside the animal and the dog classes. It can only be used within the animal and the dog classes, as we showed here. Oops, right, as we showed here. So here is a sort of a summary of the 3 access modifiers. So what I did is the same animal class. We have 3 data members that are private, age, weight, and heart. Then we have a function that's a function member that is protected, which is called breathe. And then we have the public function, which is eating, right, which can be called from the outside. So now what I say is these private members can only be accessed by animal. This is right here. The protected members can be accessed by animal and its derived classes, and the public members by anyone, right? So this is a good slide that summarizes all 3 access modifiers for a member in your class. Okay, any questions about the access modifiers? So we introduced the idea of inheritance. You inherit members, and we said that's very simple. You just use colon, and then you put the name of the class you want to inherit from. But that brought in a problem. The problem that came up was, what about access? If a member is private, can the derived class access it? The answer is no, it cannot. And it can use the public ones, but we also would like to have a third option. It can be used by base, derived, but not public. So we call that protected. Any questions about that? All right, I'll take your silence as a good thing. Another problem. See, that's the fun part of programming. We just keep getting problems, right? So we introduce the idea of inheritance, and because we introduce inheritance, we come up with a few new problems when we try to implement it. So we know that the animal class has an animal constructor, right? And the dog class has a dog constructor. You know, that's just what we know so far about constructors. So the problem is, in my derived class, in my child class, when do we construct the base instance? So in my dog class, when do I construct the animal part of the dog class, right? So this is what I mean. So the animal class has an animal constructor. Here's the animal class, which I made it public, right? So I have an animal constructor within the animal class, and it's public. And here it is, and it takes 2 parameters. It takes an integer for the age of the animal and a double for the weight of the animal, right? And then in my .cpp file, I implement the constructor. So here I have the constructor of the animal class, which takes an integer and a double. And then I initialize my age with the age parameter, the weight with the weight parameter. And then for the heart, I just make a new heart and I store it, right? Then I have a dog, and my dog class has a dog constructor. Well, here it is. This dog constructor has no issues, right? It has no parameters. It's just a parameterless constructor. And then in my .cpp, and it has a data member. This one, we added the breed, right? So we're using our enumeration that we did last week, I think, right? So we have the enumeration for the breed of a dog, right? And then in our implementation, we have the constructor dog from the class dog, and we initialize our members, right? So we initialize the data member breed. We assign it Chihuahua, right? So we default our dog to be a Chihuahua. The question here is that dog inherit from animal. When did the animal get created? Any thoughts? When did this happen? This has to happen. This right here has to happen for animal to be properly created and defined, right? So for this to occur properly, this has to happen. My question is, I have inherited from animal. I initialize dog. When did my animal object, the animal part of dog, get created? Okay, so one suggestion is that it didn't. And any other ideas? Anyone has an idea? Or another thought is it could have used the default constructor. That's not a bad not a bad idea. So the actual thing is that it didn't, right? It actually, if you try to run this code will not function. It will not work. Now, the second suggestion is it uses the default constructor. That would be a good suggestion if we had a default constructor, right? Or a parameterless constructor for animal. But here animal requires two parameters to be properly constructed. And without those two parameters, no animal can be properly constructed. So which means that this right here will give you an error. This will not work. This will say, hey, the animal class needs to be constructed and I need to give it an age and a weight to properly construct it. So this will give you an error. So how do we specify, hey, construct the animal part of the dog class? We just added in the column method at the very beginning, right? So we had breed in here. So I'm saying is before the breed, before we start to initialize the data members of dog, before we initialize these members, let's construct the animal part of dog, the thing we have inherited. So here I call the constructor animal, and then I give the values that I want for the parameters, the arguments for the constructor, which in this case would be 0 for the age, 10 for the pounds. So this is becoming a default dog. My default dog is a animal, which by default has an age of 0, weighs 10 pounds, and it's a Chihuahua, right? And then I could actually make it better and say, you know what, my dog class, I'm going to create a better constructor. This constructor actually takes 3 parameters. It takes the age, the weight, and the breed, right, to properly create the dog. So the age gets given to the constructor of the animal, the weight gets given to the constructor of animal, and then the breed initializes the data member of mbreed, right? So now here I have created not a default dog. I have created a dog with a specific set of data, a particular age. Like I could describe my dog. I have a Chihuahua. She's like 16 years of age. So I could put 16 here. She weighs like 9 pounds, I think. So she would be like 9 point something here, and she's a Chihuahua. So I can put those 3 here, and that would create a sort of a representation, virtual, of my Chihuahua, right? And the animal part of the dog is actually being created. And you add that to the beginning when you're doing the colon method to initialize your members, okay? And so we can construct one. Here I constructed a Labrador, which has an age of 1 and 55 pounds, right? So my dog is a dog of 1 year old, 55 pounds, and it's a Labrador. And you use my dog like you would normally do. All its public members that are available through the animal class and the dog class together are all the members that you have access to in my dog class or my dog instance right here. Any questions about constructors, right? So again, we introduce inheritance, very basic concept. We just try and figure out of all of our different classes that we're creating, is there something that they have in common? That thing that they have in common, I would like to define it as its own class, and then I inherit from that class. And then to implement that, we simply create the two classes as individuals, and then the class that derives, we just use colon, name of the base class. That creates, that's enough to do inheritance. Then the problem of access modifiers come in, so we introduce a new access called protected. Then the problem of constructors come in, which is when do we construct the base class or the base instance of the derived instance. We just use within the colon method, we introduce the construction, and it constructs the whole thing. Any questions up to this point about inheritance, access modifiers, or constructors?
In here, a student asked if we were supposed to use the animal constructor when we construct a dog.
So it is included, right? So what's happening is the dog class, right? This thing, when this gets called, this calls what function? This calls this function right here, right? Let me change the color to blue. No, not blue. Let me do come on, PowerPoint. Let me do green. So this calls this function, right? So this right here calls this function. And then this function, when it's being executed, when it's being run, part of it is to call the animal constructor right here. So by me simply doing this, I am doing both. I am doing dog, and within dog, I am doing animal. So it's like it's chain, right? And then it kind of goes one to the other. So that's why we don't need to explicitly call the animal constructor. It implicitly does it because the animal construction happens within the construction of the dog. Okay, so now we can create these things. Any other questions about access modifiers, inheritance, or constructors? All right, I'll take your silence as a good thing. So here's some tips. So, you know, you're writing a solution to a program and you're like, I don't know if I should make base classes or derived classes. I don't know, where should I inherit? Just because you have inheritance doesn't mean you have to use it, right? It doesn't mean that, oh, I know about inheritance, everything has to be inheriting one thing or another. It doesn't mean that you shouldn't, but it also doesn't mean that you should, right? So you have to make that call. You have to make that call whether it's worth to do it or not. And whether it's worth to do it or not might not be, it might not be enough with this knowledge that we have acquired so far. Once we learn about polymorphism, then you will have more tools to actually make the right call, right? But here's some tips when it comes to inheritance. It's all about mentality. It's all about how you go about in thinking about these things. So you can think of the base class as a generic version of the derived class, right? So here you have let me go back so you can take a look at these things right here. All of the things on the top, vehicle is a generic version of car and bus. Shape is a generic version of square and circle. Animal is a generic version of dog and cat. Same thing with browser. Browser is a generic version of Chrome and Firefox. Think of the thing on the base as generic versions of the things that would inherit from it, right? So one of the things is when you think about inheritance, you say, does it make sense to inherit? Ask yourself, is the base class a generic version of whatever you're trying to inherit or inherit from? So if the base class, you know, it's a class, some class, and then you have a class that you're like, should I derive from that class? Ask yourself, is the base class a generic form of that one, right? If it is, then maybe it's a good idea to do the inheritance. If it's not a generic version, then perhaps you shouldn't. All right, just a thought. Another way is think of the derived class as extensions of the base class. So the derived class extends the base class. So the base class is animal, the derived class is dog. It's not that dog contains everything about animal. It's that dog is everything that animal is plus something else. So it's extending the idea. All the idea related to animal is extended with the idea of dog, right? If you look at it as a shape, you can say like this is animal, and then let's say you come and then you inherit from it, and you would say that dog is the same thing as A, but it kind of like extends it a little bit, right? So A, it would be, well, it's hard to draw with the mouse, but you can think of it as like this, and then this will be the dog. So the dog is everything that A was, that animal was, plus some additional thing. It's an extension, right? So derived classes are extensions of the base classes. So if you say, hey, I have a class, I want to add more features to it, maybe I can separate it as a new class that extends from it, that inherits from it, and makes it an extension of it. And so now you have two. You have one that doesn't have the extension, in this case will be animal, and then you have another one that includes the extension, in this case will be dog. So this will be another way that you can think of base class and derived class is, do I have something that in its own is little, and then I extend it farther with new functionalities in a new way, in a new place, or them standing alone is enough, right? And the third thing you can think of is that you can think of the base class as a foundation, right? So everything about a dog makes sense because the animal class is a foundation of the dog class. If I suddenly remove the idea of an animal, then you would no longer have a dog. You would have an incomplete dog. You probably have a plushie, right? If I said, forget everything about animal, which means it had an age, weight, heart, it can breathe, and it can eat, and you're like, the only thing I have is what defines a dog different from an animal, which was it could bark, then maybe you have a plushie with a little speaker, and that's it, right? It's not an actual animal. It tries to represent the dog, but it's not an animal. So if you remove the foundation, then the class that derives from it no longer is what it used to be. So the foundation is important. So you can think of the base class as a foundation of the derived class. If the foundation is not there, the derived class is incomplete. It's not what it's supposed to be. It's a plushie. It's a picture. It's not a real thing, right? So these are three ways that you can think of it. Is base classes are the generic form of the derived classes. The derived classes are actually extensions of the base class, or the base classes serve as a foundation where the derived classes can be built on top of it, okay? I'm sure there's probably more ways to look at it, but I think these three summarize a good chunk of how you can think of classes and when should you inherit, when should you not, or what should you consider create a inheritance hierarchy where one thing inherits another and so forth, okay? Any questions about any of these three? All right, so before we're almost done, but before we wrap up, I have a question for you. The question is simple. What is the difference between the one on the left, between number 1, and the one on the right, number 2, right? Now, if you look at it, you're like, oh, well, it's different. You know, one inherits, the other one owns a data member as an animal, right? Okay, so visually speaking, we can tell what the difference is. Conceptually speaking, okay, so someone says that number 1 is an animal, right? Okay, so and number 2 has an animal. Okay, so someone said number 1 is an animal, number 2 contains an animal. All right, so when I ask what's the difference between those two, you would think that number 2 makes no sense, right? Because you would say, what do you mean by a dog has an animal? Like the dog has a pet, the dog is pregnant, like it has an animal within it, there's a parasite. Like, what does it mean for a dog to have an animal? Conceptually speaking, in the examples that we have been talking so far, where we talk about animals, in this case dog, it doesn't make sense to say that a dog has an animal, right? A dog has an animal. And in here we say dog inherits from an animal. So this is correct. One says that dog is an animal. This one says dog has an animal. This makes no sense, again, because we think about real life. But programmatically speaking, what is the difference? Because Animal has a function called eat that is public that I can use, and I can use it within my dog class. I made some random function called func, and within it I call the eat function that is part of animal. Then in my second example, I have a class called dog. It contains an animal within it. There's an animal data member. And then within that same function, instead of calling it directly because it's part of the dog, I just use its public usage relative to that data member. Programmatically speaking, I achieve the exact same thing. What is the difference? Programmatically speaking, if all I wanted was for an animal to eat 1 pound of food, number 1 and number 2, they do the same thing. Even though number 2, realistically speaking, doesn't make sense because we don't think of a dog owning an animal rather than a dog is an animal. Programmatically speaking, solving the problem, number 2 and number 1 do the same thing. Okay, so someone says number 2 is not using inheritance, but so what? Let's just say that, you know, it's not a requirement. I just say, hey, I need you to, here's 2 classes, dog, animal, and I need you to, the dog class, to call the eating function from animal to eat 1 pound. They both achieve it. Okay, someone says that the animal is an object here. That's fine. Even within this, the animal is an object that's part of the dog object, right? They're like together. So just think about the solution. Programming wise, I have achieved the exact same thing in number 1 and in the number 2. Someone said it's more work without inheritance. Okay, I can see that because just by looking at this, you can say, well, this one looks more crowded. There are some more words than in here. This looks nicer than this. I can say that you would say this is better because of that. But still, I'm just trying to provide a solution. They both are appropriate solutions. They both do the same thing. They work the same way. And if you recall in the beginning, I said you can programmatically speaking, we have solved the problem with either of the two. But in the beginning, I said we can pretty much do anything we want just by having this mechanism of owning data members, right? And then I said, well, let's just have this ability to also inherit from other objects. Now, this question is hard for you to answer because what we have talked so far doesn't really give us much more, doesn't really tell us much of the difference between the two. There's actually one difference that you guys didn't mention, and the difference is the protected access modifier. I can use the protected members here, but I cannot use the protected members here. So that is one difference. Only that is the only difference that you know of so far, at least officially. Maybe you know more from somewhere else. But officially, the only difference between this, and why this one you could call it better, is because this one right here, has protected access, has access to the protected members. Because dog does not inherit from animal, which means the protected members can only be used by the classes that are derived from animal. So it was asked, why can we use number 2? Number 2 cannot be used with protected members because the protected members are protected and they can only be accessed by the class that where they exist and the class that derives from it. There is no derivation here. Therefore, if I wanted to use breathe, remember our dog class had breathe. This one has breathe, right? But breathe is protected right here, which means that if I try to use breathe in here, I couldn't do it, whereas I could do it here. So that's the only benefit. Nope, you can't. I mean, animal, the object within it can, but I cannot say animal that breathe, because doing that something, that's basically access. That's public access, right? So the difference between these two right now, the official, based on what we know so far, is that on the left we can use protected members. On the right, we cannot, right? So you might say, is that it? Like we created inheritance and all these things just for protected access modifier? Well, the answer is that it's not very obvious what the difference between the two is until we talk about polymorphism. Once you know about polymorphism, you will know that this right here is a completely different beast. And I'm not talking about beast from the context of animals. I'm talking about programming beast, okay? This thing right here is very powerful. And once you know about polymorphism and all the things about polymorphism, you will realize that there's a lot of things that you can do with number one that you cannot do with number two, okay? So right now, it's not very obvious, other than the protected axis modifier. The rest is the exact same thing. And once we talk about polymorphism, it'll become more clear. So the last slide to talk about or the last thing to talk about, which connects to it, is when we talk about inheritance, or when we talk about an object owning another object. So here, dog inherited from animal. Here, dog owns an animal. This is a relationship, right? So classes have a relationship. The relationship that these classes have is either one of these two. Either a class can inherit from another, or a class can own an instance of another. That's it. Those are the two relationships that you have between classes. The one on the left is called is-a relationship, because a dog is an animal, right? Chrome is a browser. A square is a shape. A hammer is a tool. A table is a surface, right? So when you see inheritance, this is an is-a relationship, because the class that it's deriving is also what the base class is in a much more generic form, kind of what we talked about earlier, okay? The other type of relationship is when a class owns an instance of another class as a member. That's called a has-a relationship. So a dog has an animal. Okay, that doesn't make a whole lot of sense because we're talking about real life. But still, programmatically speaking, here a dog has an animal. Another one would be a dog has a heart, or the animal has a heart, all right? So there is a has-a relationship between classes, and then there is an is-a relationship between classes. You don't have anything else other than those two. So to summarize it, objects have one of three relationships. I know I said two, but there's a third. And the third one is no relationship at all. But the first one is a relationship, which connects to inheritance. So inheritance is the equivalent of an is-a relationship. Has a relationship is when an object owns another object as a data member. And of course, the last one is there's no relationship, like the dog and the cat. The dog and the cat are two separate classes. They don't talk to each other. They don't inherit from each other. They don't own each other. So the dog and the cat, they are two classes that have no relationship with one another. They're just completely independent, right? So that would be the third relationship, no relationship. But that is the default, right? The default would be that two classes have no relationship. Then you can define one of the other two, which is either is-a and has-a. Which one you do? The one that's more appropriate. Which one should you do? Well, right now, the only difference we know between is-a and has-a is we said the protected axis modifier. That's the only thing we know. When we know polymorphism, you will know there are more things that come with the is-a that you don't have with the has-a, and that's what might help you decide which of the two should you have. It's not that one is more important than the other. They're both equally important, but sometimes one is more appropriate than the other for a particular thing. And you can think about this as you go about your daily life, right? You can say, I have a hat. Okay, that's a has-a relationship. I am not a hat. Okay, I am a human. That's an is-a relationship. I don't own a human, right? That would be bad. Okay, so then you can start to think about all these things about, okay, here's a burger. The burger is a piece of food. That's is-a relationship. Here's the burger. The burger has lettuce in it. That's a has-a relationship. They're both important to the object-oriented world because they describe how objects relate to one another. Any questions about inheritance? And we're going to talk about polymorphism next, okay? And then polymorphism, but guys, it's very important to understand what we just talked about, because polymorphism builds on top of inheritance. So if something about inheritance just kind of like lost you, polymorphism will leave you more behind. So when it comes to inheritance and polymorphism, it's very important to understand inheritance very well before we move to polymorphism. And one thing that I did not mention on these slides is that you can have derivations that continue, right? So here my, let me go back. Since we have 10 minutes, we can talk a little bit more. Sure, why not, right? So here, for example, animal is a general version of dog. Well, dog is a general version of what? Of, let's say, Chihuahua. I'm just going to put Chihuahua and then a Labrador, right? A dog is a general version of Chihuahua and Labrador. And then I have my dog, which is Chickies. Her name is Chickies. So let's just say, I'm just going to say Chick, right? A Chihuahua is a general version of Chickies, right? And so I can construct a hierarchy of more generic to less generic, and then that's how I build inheritance. So Chickies could inherit from Chihuahua, and Chihuahua inherits from dog, and dog inherits from animal, right? That's perfectly fine. I mean, for car, you could also say something the same. You can have a 2-door car, you can have a 4-door car. For bus, you can have like the Metro, and then over here you can have the Mega Bus or whatever they're called, Mega Bus, right? So you can continue to have, you can have a mess when you come. Well, it's not a mess, but you can have a bunch of links where you have a class called Mega Bus, and the class Mega Bus inherits from the class Bus, and the class Bus inherits from the class Vehicle, and then the class Vehicle can be something that inherits from, let's say, a transportation system or something. Well, I can't really write with my mouse, but this will be like a transportation system, and then and you can have a whole crazy hierarchy. You can have also the store. Maybe from the store you have an establishment or a building, a browser. You can call this software, right? Software, right? And so on. So you can continue to go up and you can continue to go down. When should you stop? It just depends on what you're writing, what's your software. If the only thing you care about are browsers, then you don't keep going up. You don't go to software. Why would you, right? If you are supposed to go to like Chrome tabs, maybe I don't know what you would put below here, to be honest, but then maybe this is the stopping point right here. We stop at Chrome. We don't need to keep going down even further. Same thing with our dogs, right? If you don't need to specify a particular dog like my Chihuahua very specifically, then you just leave it at generic Chihuahua or a generic dog, and that's good enough. How specific you want to get with your inheritance hierarchy depends on how much information, how detailed you want to be. If you don't care to be that detailed at the bottom levels, then you exclude the bottom levels. If you don't want to be too general to the point where you have a bunch of parent classes going all the way to the very top, then you chop off some of those parent classes at the top, right? This is it depends. It depends on what you're doing. And by applying the tips that I put here, you can break it farther into, where are they at? Where are my tips at? By implementing these tips, this is kind of how you can decide which one seems appropriate and when. And so we will talk more about having multiple inheritance, as I mentioned with this chain, once we start talking about UML, right? So we'll talk about UML, how do we make them diagrams, which we kind of already know in a way, since that's kind of how we describe our dog, our giraffe, and everything.
All right, well, that is the lecture on inheritance. I hope that you found it useful, that you enjoyed it. I plan to post a few of the other lectures as well. I will try and post the polymorphism as well, so you should be able to see a link in the description, or I'll probably just give a note at the end, or I'll probably post a note. You've probably seen it by now, right? So if you want to continue on and learn what's next after we have learned about inheritance and what we can do with polymorphism, then make sure you check that out as well. All right. So if you like this video, you found something useful and you don't mind, drop a like. If you're new to this channel, check out the channel. And if you like what you see, subscribe, be safe, and peace out.